All right, let's pick up with the second half of lesson 8.3, parallelogram proofs. At the top of the page, you'll notice what it says. Properties of parallelograms are sufficient to prove a quadrilateral is a parallelogram. The list below summarizes ways to prove a quadrilateral is a parallelogram. In part 1 of this lesson, we went back to the definition of parallelogram every single time. However, now that we remember all these other properties, we can use them to prove that a quadrilateral is a parallelogram. We can show that both pairs of opposite sides are congruent. If we can do that, we've proven a parallelogram. Same thing with the pairs of opposite angles. If we can establish that those are congruent, then we have a parallelogram. We can show that the diagonals bisect each other, or we can show that one angle is supplementary to both adjacent angles, or show that one pair of opposite sides are congruent and parallel. That will shorten a lot of our proofs. So let's take a look at example 7. Example 7 says P is the midpoint of Ln and Km. Let's mark that on the diagram. So these two pieces are congruent and these two pieces are congruent. And we're asked to prove whether or not KLMN is a parallelogram. Well, let's begin by stating all our given information, right? P is the midpoint of Ln and Km. And we'll mark that it's true because, of course, it's given. Well, just like we marked in the diagram, we have some congruent segments, so let's establish those. We can say that LP is congruent to PN. Then I'll put a little colon here, and we can say that KP is congruent to PM. Right? The reason for that is the meaning of the word midpoint. So we can say definition of midpoint. Now you'll notice these statements in number 2 tie in very specifically with one of our properties of parallelograms, namely that diagonals bisect each other. So we can now conclude that KLMN is a parallelogram. Why? Because the diagonals bisect each other. And so we need to write that down. We can say diagonals of, and you can just call it para to abbreviate, bisect each other. All right, let's move on to example 8. In example 8, we are told that there's a pair of congruent triangles inside this quadrilateral, right? Triangle EDG is congruent to triangle GFE. So let's go ahead and establish that as our given statement. Triangle EDG is congruent to triangle GFE. And that's true because, of course, it was given to us. Now, there's lots of markings that we can make on the diagram here. I'm just going to do this. I know that if these are congruent triangles, that their corresponding sides are congruent, right? I know that DE, as I can see here, corresponds to GF, and they're congruent. I know that EF, which is right here, corresponds to DG. Let's mark that as our second statement. ED is congruent to FG. Then put a little colon. We can say EF is congruent to DG. And that's because corresponding parts of congruent triangles are congruent. Because we knew these two triangles were congruent, we know that their corresponding parts are congruent. And we can basically finish the proof here. We have to determine which one of our parallelogram properties this is fulfilling. We have shown that both pairs of opposite sides are congruent. So we've done that. We can say then that DEFG is a parallelogram, specifically because opposite sides of a parallelogram are congruent. All right, let's move on to example 9. In example 9, we're given this information. Angle XWZ, that's this whole angle, that's all of angle W, is congruent to angle ZYX. That would be this angle here, or all of angle Y. We're also told that the two triangles inside this quadrilateral are congruent to each other. So let's begin by marking down all the given information. Angle XWZ is congruent to angle ZYX. Put a little colon here. And we can say triangle WXY is congruent to triangle YZW. And again, all of that's true because it was given to us. The question becomes, which property are we going to use moving forward? The fact that we have congruent triangles probably means that we're going to be using that, and CPCTC, right? The fact that corresponding parts of congruent triangles are congruent, to mark something else congruent on our parallelograms. But what are we going to use? Well, what I observe here is that I have a pair of opposite angles congruent. It would be really nice if we could mark the other pair of opposite angles congruent, like this, right? Because one of our properties says that, show that both pairs of opposite angles are congruent. Well, let's do that. In statement 2, we can even just call it angle X is congruent to angle Z, because there is only one X and Z angle. We can say that they're congruent because corresponding parts of congruent triangles are congruent. We can confirm that too. X and Z correspond within the triangles. Now that we've done that, we can establish then that WXYZ is a parallelogram. The reason why is because opposite angles in a parallelogram are congruent. Awesome. Let's go ahead and flip the page. This will be our final example. Let's begin by marking the diagram. First, we're told that QS bisects segment RT. So we know that RV is congruent to VT. We're also told that angle RSQ is congruent to angle TQS. So RSQ, that's this angle here, congruent to angle TQS. That would be this angle right here. And we're asked to prove that QRST is a parallelogram. Let's begin by marking all of our given information. So our first piece of given information said that QS bisects segment RT, and it was given. And I'm going to go ahead and put this on a new line here. I'll say that angle RSQ is congruent to angle TQS. Again, because it was given. Well, the first thing, think about the markings we made. The fact that QS bisected RT told us that RV was congruent to VT. So we should mark that as our third statement because we marked it on the diagram. RV was congruent to VT because we understood what the word bisect means. So we could say definition of bisector. The next conclusion we can make is based on the second piece of given information. We see a pair of alternate interior angles are congruent. That would tell us then that RS is parallel to QT. So let's mark that as our fourth statement. We can say that RS is parallel to QT. And the reason why? We have alternate interior angles, and it's the converse. Again, we noticed alternate interior angles were congruent, and we used it to prove that lines are parallel. That means we're using the converse. Now we need to see what approach we're going to take to prove that this is a parallelogram. Well, I noticed that we have one pair of parallel sides. It would be wonderful if we could prove that we have two pairs of parallel sides, but there's not a lot of information that we can use to help us prove that RQ is parallel to ST. However, another option, if we can somehow prove that RS and QT are also congruent to one another, if we could do that, we could prove that this is in fact a quadrilateral. Well, one way to prove that they are congruent, I'm going to erase those markings because we haven't proven it yet. But one way that we could prove that, if we can prove that triangle 1, for lack of a better name, is congruent to triangle 2, then using CPCTC, we can show that RS is congruent to QT. Let's try that approach. So we're very close to being able to prove those two triangles congruent. Right now we have a pair of congruent angles and a pair of congruent sides. But traditionally we need three things like side, or angle, or angle, side. What you may notice is that we have vertical angles right here. This angle here and this angle here are vertical angles. So let's establish that. We can say that angle RVS on the top is congruent to angle TVQ on the bottom. And that's true because they are vertical angles. Vertical angles. Now that we've done that, we have angle, side. Angle, side. So we can conclude that the two triangles are congruent by the angle, side congruence postulate. We'll call the top triangle RVS. Triangle RVS is congruent to triangle TVQ. Now that we've done that, that allows us to say that RS is congruent to QT. RS is congruent to QT because if you remember, corresponding parts of congruent triangles are congruent. We can even check it. R and S, that's first and third letter. T and Q, that's first and third letter. Now we can finally conclude in our last statement that QRST is in fact a parallelogram. Specifically, if we want to look back, we've got all those properties on the previous page, right? We have shown that one pair of opposite sides are both congruent and parallel. Okay. We can write that down like this. We can say one pair of opposite sides in a parallelogram is congruent and parallel. All right, thanks for watching.